right, here we're looking at 7.5, and our learning targets are use properties of trapezoids. Then we're going to use the trapezoid mid-segment theorem to find distances. We're going to then use properties of kites, and finally we're going to identify quadrilaterals using all of the information that we know to figure out what exactly kind of a quadrilateral it is. So first we have to show that QRST, ORST is a trapezoid, then decide whether it's isosceles. So let's back up really fast. So what is a trapezoid? A trapezoid is a quadrilateral that has exactly one pair of parallel sides, right? We've been dealing with parallelograms where both opposite sides are parallel. Here we're only going to have one. There's a special kind of trapezoid that we're also going to be talking about, and these are horrible drawings. So here I would see that these are parallel. If these two sides, these are the legs, right? And the parts that are parallel are called the bases. So if the legs are both the same length, then this would be an isosceles trapezoid, right? Just like in an isosceles triangle, the two sides are the same with an isosceles trapezoid. So here we are back with this problem. Show that ORST is a trapezoid, then decide whether it's isosceles. So in order to show that this quadrilateral is a trapezoid, I need to show that one set of opposite sides is parallel and the other set is not. So let's look at the slope here from R to S. So I see slope, I go rise over run, so I see I go up 1 and over 2. So I go up 1 over 2. This is the slope of RS, right? And I want to label this and make sure. So now let's look at OT, because that is the opposite side from that. So I can see that my slope, I go up 2 and I go over 4. So I go up 2 over 4, and this simplifies to 1/2. So I see here that the slopes are the same. So that's a good start. Now let's look at the slopes of my other two sides. So here between OR, I see that my slope is undefined, right? Because I go up 3 and I go over 0, so I'd be dividing by 0, which gives me this undefined. So now let's look at ST. So from S to T, I see I go down 2 over 2, which simplifies to -1. So since these two slopes are not the same, but these two are, I can say yes, it is a trapezoid. Okay, so now I have to figure out whether it's isosceles. So I need to find the lengths of the two legs. And the two legs here, we're going to go them in green right here. So here's one leg, and here's the other leg, because these are the two sides that are not parallel. So the length of RO, right, I can see is 3, because it goes along a straight line, so I can just count as 3. So here for the length of ST, I have to use either my distance formula, or I can turn this, right, into a triangle with side lengths 2 and 2, and I know that a squared plus b squared equals c squared. So I can substitute my a is 2 and my b is 2 equals c squared. So I end up with 4 plus 4 equals c squared. So to get c by itself, I've got 8 equals c squared, and then I take the square root of both sides, square root of 8. This is not something that I know, but I also see that it is not the same thing as 3. So I know that RO is not the same distance as ST, so it is not an isosceles trapezoid. It is a trapezoid, but it's not isosceles. So again, we're going to be working with slopes and distances in our points. So keep that in mind as we keep going on. So here's your first monitoring progress. Here you're not given the coordinate plane. So the first thing I would do is I would draw this out on the coordinate plane so I have a picture to work with. So now here are some theorems that we're going to work with. So this first one, the isosceles trapezoid base angles theorem. So if a trapezoid is isosceles, right, where my legs are the same length, then each pair of base angles is congruent. So if my legs are the same length, that tells me that A is congruent to D and B is congruent to C. The two angles that share that parallel side would be congruent. So now let's look at the next theorem. Isosceles trapezoid base angles converse. So if a trapezoid has a pair of congruent base angles, so if I know that A is congruent to D, then I know that these two side lengths are the same, so I know that it is an isosceles trapezoid. So the difference between these two theorems is this first one is I know something about the side lengths, so then I can say what I know about the angles. In the second one, I'm given information about the angles, which leads me to what I know about the side lengths. So then here's our isosceles trapezoid diagonals. So a trapezoid is isosceles if and only if the diagonals are congruent, right? And that would kind of make sense because if we draw this into triangles, remember our congruent triangles? If I know one side and the others are similar, then I know that these have to be the same length. And we're talking isosceles, right? Non-isosceles trapezoids, their diagonals can be any length. So let's look at this. This is example number 2. The stone above the arch in the diagram is an isosceles trapezoid. So find the measures of angle K, M, and J. So I'm given the measure of angle L. Well, I see that K and L are on the same parallel line. So I know that K is going to have the same measure as L. So the measure of angle K is equal to 85 degrees. So now I have to figure out what I have left between J and M. So this is a quadrilateral, so I know it has a total of 360 degrees. So I know that that 360 equals that 85 plus X, we're going to call it, plus X, right? And I know that these are also the same because I'm told this is an isosceles trapezoid. So I know that since I have this 85 and this X, I also know that 180 minus 85 will give me X. Right? So if I can cut this in half, I know the other measures of my angle. So I know that X will end up being 95 degrees. Okay? And that is true for J and M because they are the same. So the measure of angle J equals 95 and the measure of angle M equals 95. Okay? So I can take what I know about one angle and use that information to help me find the rest of the angles using my isosceles trapezoid. So here are some more monitoring progress. Try them and see what you come up with. So now we're looking at our second learning target using the trapezoid midsegment theorem. Okay, so here's my midsegment. The midsegment of a trapezoid is parallel to each base and its length is 1/2 the sum of the lengths of the bases. That's kind of big and confusing. So a midsegment cuts both of the legs in half. So you'll see here that AD is one leg. My midpoint M cuts that in half. My other leg BC is cut in half by N. So then MN is my midsegment. So I know that it is also parallel to my bases, as shown by these arrows, and that if I add AB and DC together and divide by 2, I will find the length of MN. So it's kind of finding the average of the two bases to find the length of my midsegment. So here's example number 3. So in the diagram, MN is the midsegment of the trapezoid. Find the length of MN. And I know that it's the midsegment because I see that it cuts both legs in half. Well, I know that to find the midsegment, I have to add the bases together and divide by 2. So I have 28 plus 12, which gives me 40, divided by 2, which is 20. So the length of MN is going to be 20 inches. So it's simple as that. I take both bases and I add them and then I divide them by 2. Here's example number 4. So now we're using our coordinate plane. So I have to find the length of the midsegment in this trapezoid. So the first thing I really have to do, right, and I can't guarantee where these points are, and then this point is in a weird spot, so I can't go ahead and just find the length here. But I can see both of my bases and I can find the lengths there. So let's find the length of SV. And I notice here too that my coordinates go up by 2. So I see I have a triangle with a length of 2 and a length of 4. So I have 2 squared plus 4 squared equals c squared. So I've got 4 plus 16 equals c squared. So I've got c equals the square root of 20. Okay? This can be simplified to be 2 times the square root of 5. We need to talk some about simplifying radicals, but we can live here as well. It's the same kind of thing. So now let's find TU. So again, I'm going to draw my triangle, and I see I go up 2, 4, 6, 8, and I go over 4. So I have 4 squared plus 8 squared, which is 16 plus 64, which is going to be 80, and the square root of that. So I end up with 4 times the square root of 5. Okay, so these are my two values. So what I do is I add them together, and then I divide them by 2. So if I add 2 times the square root of 5 plus 4 times the square root of 5, I end up with 6 times the square root of 5. So then I divide by 2, which equals the 3 times the square root of 5. Okay? So we always want to live in exact answers here with our radicals rather than going to decimals. So now I want to talk briefly about how I go from here to here, right? This is kind of a big step. So I look at 20 and I want to ask myself, is 20 divisible by 4? Which it is. So now I know I have the square root of 4 times the square root of 5 because 4 times 5 is 20. And I know what the square root of 4 is. The square root of 4 is 2. So I end up with 2 times the square root of 5. So let's look down here at 80. Do I know that 4 can go into 80? Well, yeah, I do. So now I know I have 4, the square root of 4 times the square root of 20. Because 4 times 20 gives me 80. Okay? I'm not quite done yet because I see that I can simplify 20 a little bit too. I know that 20 can be broken down into the square root of 4 times the square root of 5. Well, I know what the square root of 4 is. That's 2. And this is 2. And this is the square root of 5. 2 times 2 is 4. And the square root of 5 is left. So come talk to me if you're still having trouble simplifying these radicals. So here's your more monitoring progress. Look at how you can do these. And draw them out always and label what you have so that you can know what you're looking for. Okay, so now we're going to be dealing with a kite. Let's first talk about what a kite is. So a kite, right, we've all seen kites. A kite has no sides that are parallel, but they have consecutive congruent sides. So these two that are next to each other are congruent, and then the two at the bottom are congruent as well. But opposite sides are not congruent. Okay, so let's look at our kite diagonals theorem. So if a quadrilateral is a kite, then its diagonals are perpendicular, as denoted by this little box, right? So again, here's some information that I need to know, that this intersects at a 90-degree angle. So now my kite opposite angles theorem. So if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And you see here it's angle C and angle A. And you'll notice that these are the two between the other sides, right? So angle B and angle D, even though D is between congruent sides and B is between congruent sides, they are not congruent to each other. So it's the ones that are opposite the congruent sides. So now let's use this information in example number 5. So I'm asked to find the measure of angle D, which is right over here. Okay, I'm told the measure of this angle, and I'm told the measure of this angle. So now I know what's left. So if I look back at my kites, I know that D would be congruent, angle D is congruent to angle F because they're opposite of each other and they're kind of each between the different sides. So I know that D is congruent to F, so they have the same measurement. Well, I know that there are 360 degrees in a kite because it is a quadrilateral. There are 4 sides, so I know there's 360 degrees. So I'm going to go ahead and label these as X. Right? Because they are the same, I can give them the same value. So I know I've got 115 plus 73 plus X plus X. So now let's simplify. I've got 360 equals 188 plus 2X. So now I'm going to subtract my 188 and simplify from there. Right? So I've got 172 equals 2X. So then when I divide by 2, I end up that X equals 86 degrees, right? So I know that the angle, the measure, that's what this M stands for, the measure of angle D is 86 degrees. So here is a monitoring progress to try and do something similar. First, always draw it out and see what you can come up with. So here's example number 6. What is the most specific name for quadrilateral ABCD? So if you look on page 402 in your book, it gives you a nice kind of diagram to identify special quadrilaterals. And we're going to use that to help us here. So the first thing I'm shown is that BE and DE are the same length, and that AE and EC are the same length. So I know that the diagonals bisect each other. So I know, I'm going to go ahead and click through this one. So the diagonal's bisector. By the parallelogram diagonal's converse, right? I know that it's a parallelogram. So I can start with that information. So rectangles, rhombuses, and squares are also parallelograms, but I'm not sure which one this is. So I'm not given any information about side lengths or angles, which I need in order to determine anything specific about these three things. So I can't actually say if it's a square, a rectangle, or a rhombus because I'm not given enough information. So the most specific name that I can have for this one is a parallelogram. Okay, so I want to look at these a little bit. We're going to skip number 7 right now because I want to look at these. So let's look at number 8. So I see that I have this side length is 51 and this side length is 51. This one and this one are both 50. So I'm not told anything about the angles and I'm not told that they are parallel. So I can only say that this is a kite because these two are the same and these two are the same. Let's look at number 9. So I see that I have one set of parallel sides, so I know that it is a trapezoid, and then I have some information about these lengths, and if I add these together, I see that 64 plus 80 is not the same as 75 plus 62, so it's a trapezoid, but it's not an isosceles trapezoid because my diagonals would be the same. Okay, so then this one, I am only told that these two opposite sides are the same length, that this diagonal was bisected, and the length of this side. This does not give me enough information to know specifically what kind of a quadrilateral it is. I don't know for sure that any sides are parallel. I don't know anything about the angles. So I have to leave with this as quadrilateral. Okay. So let's look back at our learning targets and see how we did. Okay, so the first one was using properties of trapezoids. Keep in mind our special trapezoid, our isosceles trapezoid, because that has different ideas and things that we can use. Our second learning target was use the trapezoid mid-segment theorem to find distances. Our third one was use properties of kites. And then fourthly, we used some of this information to help us identify different quadrilaterals. And again, it's on page 402, is a nice chart that helps us to identify different quadrilaterals. So now that we've gone through this, please go ahead and start working on the homework for 7.5.